Hello, everyone. I hope you guys are doing very well. So today we're going to talk about data cleaning. That will be the topic for today. And I usually obviously see data cleaning as the foundation for reliable data analysis. And the reason why I'll call it the foundation is because if you don't get your data cleaning right, your data reports, data visualization would pretty much not be trustable. It won't be trustworthy, basically. So in this session, we're going to understand the concepts behind data cleaning and how to make a data reliable and complete. So we're just going to go to the next slide. Perfect. So what is data cleaning? So data cleaning is the systematic process of identifying and correcting issues within a data set to improve overall data quality. Now, these issues could range from blank rows, null values, errors, wrong formatting of a column, inconsistency in the data, or even data incompletion. So what is the key purpose of data cleaning? It's to help improve data accuracy and consistency, to ensure the data is complete and also usable for reports and visualization. And it's to also prepare it for data analysis and reporting, because a clean data is more reliable, more accurate and consistent, which makes it essential, an essential stage before analysis, reporting, or decision making. So why do we clean data, and why is data cleaning important? Data cleaning is very important because without data cleaning, the data that if you try to take a dirty data, for example, and you try to visualize it, you try to create a report from it, that data is not telling the truth about what is actually going on, because it is not reliable. You might have some duplicates, therefore that might skew up the numbers that you're aggregating as the total of something. A very good example I'll give is, and before I even give that example, I just wanted to make this note that data cleaning doesn't only mean removing errors, removing blank rows, removing duplicates. It also means to check if the data is actually complete. And a very good example I'll give is something I experienced of recent while I was trying to create a data report at my workplace. So I had two should I say, data sources. One was an Excel file that contained like a list of students and what their engagement with a specific service, and another one was like the data flow that contained the student details. So that included all of their, should I say, phone number, their address, their course, if they were undergraduate and postgraduate. So the initial table in the Excel file that contained the student number, obviously, which was what I was using to link the two tables, and the engagement with that service was complete. That data was clean. I cleaned it. Everything was fine. However, the student details data flow wasn't. And this was the data flow that was provided by the, should I say, higher ups of like the data team to myself. And why that data wasn't clean, if I should say, was, yes, I did have to remove duplicates. I did have to remove blank rows and all of that stuff, but it was majorly because it wasn't complete. So the time where I had to get the total value of the students that had engaged with that service, we got the actual correct value. But when I had to connect it and then break that value by how many undergraduate students had engaged with that service, how many postgraduate students engaged with that service, we started seeing discrepancies. Because if the total value, for example, let's say was 9,000, and then undergraduate is saying, if you filter by undergraduate, is telling you, 2,000 or something students, and then postgraduate is also telling you maybe 3,000 or something. Adding those two numbers up to make up 9,000. That was where I was able to notice, okay, there is something wrong with that data flow. After inspecting the initial Excel file that contained the student details and then inspecting the data flow. And how did I do that? I basically took several student numbers from the complete data set and then cross-checked if they existed in the data flow. And I noticed for a lot of students, they didn't exist. And that was how I was able to raise that issue, to have that data flow checked again and processed to ensure that it contains all the student records. So this is a good process of data cleaning. Let's say I wasn't taking necessary procedures to make sure that the data was clean, to make sure that the results that or reports that was given was correct. I could have just gone with, oh yeah, undergraduate students is 2,000 or something, postgraduate students 3,000 or something, and that's it. And that report would have been very, very wrong. So that's why you have to make sure that you clean your data, you check for completeness, and that's the importance of data cleaning. So I'll just go back into the slide and continue from where I stopped before the example. So first of all, why data cleaning matters is quality drives results. So analysis depends entirely on the quality of the underlying data. So poor quality data produces unreliable results, which is exactly just like the example I gave. It also builds trust. So cleaning improves your trust, clarity, and reliability in all downstream reports and visualization work. So basically, if you're sure that you've cleaned the data properly, and then you visualize the data, you've reported the data to, let's say, your manager, for example, and they kind of like think, oh, there might be something wrong in this data, and you're sure you've taken the necessary steps, you've ensured the data is cleaned, you have that trust in you to make sure that that report, what is telling you right now, that number is correct, because you've done your data cleaning and you've ensured that that data is well managed and clean before you actually started visualizing or reporting. And the last thing is it also helps you prevent problems. So it helps you address issues early by reducing errors and complications before actually having to then experience those discrepancies when you're reporting or visualizing, and then having to go back to do those things. So a good analysis basically starts with clean data. Without proper data cleaning, even the most sophisticated analysis techniques produce misleading results. So what makes data dirty? Data is considered dirty when it contains issues that compromise quality and reliability. Some of the issues are missing values, the empty fields or incomplete entries, duplicate records, repeated entries that skew results, inconsistent formatting, varied styles and structures. For a good example of that is if you have two date columns, and one of them you have just let's even say an American date and the other is a UK date. That is inconsistent formatting for the date columns. Or let's say one is date and time and the other is just date. In some cases it might be useful. In some cases where you might want to compare those dates together, that could also be an issue, inconsistent formatting. So spelling errors as well. Inconsistencies in the spellings could actually skew your data. For example, if you have a list of, let's say, countries and the products that they produce in that country, and let's say there's United States, you have several ones, and there's one linked written as United States without the S. Now, if you're trying to group those data together, or you're trying to filter by United States, you're missing a specific record that is meant to also be should I say, joined as part of that group or that filter, because what you're filtering by is United States. However, there's a record or a couple of records that are in the name United States. So those are things you want to look out for to ensure there's consistency in the data all through. And then also invalid entries. So data outside expected ranges could also skew the data. A good example is if you're maybe doing an aggregate or looking, there's a column which is like an aggregate between 0 to 100, and then there's a couple of records that have 120. That's outside the expected range. And the best way to even tell this is by percentage. If you're dealing with percentages, you know it shouldn't be more than 100%, except you're trying to deal with, let's say, profit percentage, where you can have 110% of how much was put in. That's a different case. So you also need to be aware of like the context to ensure that your entries are valid or they're not valid. And then structural issues, there's wrong data types or formats. You know, if you're formatting numbers as texts, in some cases it's good, in some cases it's not. And the reason why I said in some cases it's good is if you were to do data cleaning on Power BI, for example, and you had student numbers, for example, some student numbers will start with 0, 0, 1, 2, 4, 5, for example. That's a very, very good example and, you know, simple one. If you format as a number, it will get rid of the zeros at the beginning. And you wouldn't want that, because then that will bring inconsistency to the data, where you have student numbers that are like, what, let's say 5 digits, and you can find specific ones in that same column that's about 3 or 4 digits. So this is where, again, like I said, it might be beneficial to just keep it as text. But this is something that you have to make that decision by yourself to say, okay, I want to keep this, not because of ignorance, like you didn't notice it or you didn't make that decision for yourself. So you have to be sure that you're actually going through the necessary steps to ensure that your data is exactly the way you want it before you start reporting on that data or start exploring that data. Another one is extraneous content, unnecessary spaces or characters in between values or fields. This is very useful if, for example, you're trying to report on, let's say, a sentence. You know, there are tools in reporting platforms that you can use to basically look at the most entered words, the most used words, and things like that. So in this kind of scenarios, you want to just make sure that there are not unnecessary spaces. And sometimes it could even be when you're formatting someone's name. You know, let's say for example, my name is Oluwatimileyin, right? There might be a space before the O, and if I had, let's say, in a data where I've made a couple of purchases, that could filter my name into two different filters, where one of them, it looks normal, but there's a space before it, and the other one is tight. There's no space on either edges. So this is where you also need to like trim it. So removing spaces is called trimming. And then outdated information, you want to check if the information is up to date and is useful for the report or visualization you're trying to make. So these are pretty much things that could make a data dirty. So what is the main goal of data cleaning? The first is accuracy. You want to ensure that data values are correctly represented with real-world information without errors. The second is completeness. You want to fill the gaps and check for missing elements to create a full and usable data set. Just like the example I gave, missing elements there was student records that was missing in the student details data flow that I had. So these are things kind of things you want to check for. Consistency. You want to check that there are standardized formats, spellings, and structures across all records. So it is consistent. And a good example was the one I gave about the United States, where there's United States and there's one without the S at the end. Then validity. To verify entries match expected results and fall within acceptable ranges. And then reliability, to build confidence that data can be trusted for decision-making purposes. Because if you know deep down your data is not clean, you know that whatever results you're getting and whatever decision you're making based off of that data might not be correct. But if you ensure adequate data cleaning for your before you start reporting and start making decisions based off of your report, then you're sure that you're making a good report or a decision that is backed by the data fact. So what are the core tasks in data cleaning? Data cleaning involves a couple of activities to identify and resolve data quality issues. The way I approach it, so for different data, you can approach it in different ways, right? But I'd say this is not exactly like the step by step, do this first before you do this, because different people could do it different ways. Personally, sometimes the first thing I like to look at is the data types. Are the data types correct? Because if the data types are not correct, it would cause inconsistencies where I would not be able to actually spot duplicates. For example, a good example is dates. If the data type for dates is not correct and that is not formatted correctly, there might be actual duplicates, but because on the date format is showing, because there's this thing with date columns where if you don't correctly do the date column, you might have some in date format, you might have some in, like, should I say, not hexadecimal, but it's like in a, I've forgotten what it's called. It's kind of like a good example. I'll just give you like 4 point something f times something 10 raised up or something. Like, it's just a weird, like, weird format or code for the date, right? So that format, if you format it properly, or that date format, if you format it properly and it changes to a date, it might actually mean that that whole row is a duplicate of another row. But if you wouldn't know if you don't make sure that data format is correct. So just again, like I was saying, this is not like for you to say if you have to remove duplicate first and you have to handle missing data, you have to correct formatting. You can do it in different ways. As you go, you definitely find your own rhythm and way of approaching it. But some of the steps are: one, to remove duplicates. This will help you identify and eliminate repeated records, because you do not want duplicates in your data, as that would skew your visualization or your reports. The second is to handle missing data. You want to address empty fields appropriately. So there's some data that are fine if they are left blank, because they're not really necessary, while there's some data that are very crucial to your visualization or your reporting if they're blank. So these are where you need to identify what is the goal of this report or that I'm trying to make. What are the essential columns or features that I need from this table, from this database, for me to be able to give out a good, accurate report. And that's where you then identify certain important columns that have to have a value in them. And then you can go about sorting out missing data. This could include reaching out to teams and confirming the actual data for that specific record, things like that. Correct formatting. You have to make sure that the dates are standardized, numbers and text formats are correctly done. You want to standardize the values as well, ensure there's consistent spelling and terminology. And then fixing structural issues. You want to correct the data type mismatches and schema problems. Then another one is to validate the entries, to check values against defined rules to ensure that it's correct. Very good example is if you want to say, let's say for example, you want to create a column and you want and that column is a new column and it's based off of another column, a conditional column, right? And you want to say if let's say product A is more than £5, put it as cheap. If product B is more than £20, put it as expensive. Things like that. You want to make sure that your entries are validated on that initial column that you're basing your condition off of, so it can give you the correct value on your new conditional column. And you also want to ensure that your condition as well is correct, so that the values that are being displayed or the results or result here from the condition that's been displayed on the new column is also valid. And then you want to identify outliers, detect unusual or extreme values. So outliers are basically things that could completely throw off your data, completely throw off your report, where let's say a data seems to, let's say you have a line graph, right? And most of the data seems to be around this point, and then all of a sudden you have one data here and like another data here. Those are outliers, and so it's very good to inspect the outliers to be sure that it is safe to remove them from your data, so that your information or whatever report you're creating could be consistent and accurate. And then another step is to verify the data types, like I mentioned before, to ensure that the data types are correct between numbers, number data types, texts, dates, and all of that sort. So what is the difference between data cleaning and data analysis? So data cleaning, the purpose of data cleaning is to prepare and structure data. And in data cleaning, we focus on quality and structure. We try to fix and correct errors and inconsistencies, and then we ensure the data is ready for use. Whereas data analysis is the purpose is to interpret and derive insight, to gain understanding from what the data is holding, to then be able to make a decision based off of that understanding. And with this, we focus on meaning and patterns. We try to extract insights from the prepared data, and we try to support decision making. So data analysis would be flawed if data cleaning is not done correctly. So data cleaning is a fundamental stage to a correct data analysis. So the key point basically is you have to clean your data first so you can analyze with confidence. The two processes are connected but distinct. So what are the common challenges in data cleaning? The first challenge is multiple data sources. Data may arrive from various systems with different formats, structures, and conventions that must be reconciled. What this means is if you have different data sources, I'll give you a good example, which is what I gave before, which was the Excel file, the data flow. Let's say we have another Excel file, and all of these are all student data, right? You have to make sure that the data format for the student ID, for example, is the same and is consistent across all tables or databases. Because if it's not, you won't be able to create a correct relationship between those tables, whether it's a one-to-one relationship, many-to-many relationship, one-to-many, or many-to-one. You won't be able to create a correct relationship because it is not correctly linking those columns, right? Because of the data types. So these are issues that you can face when you're trying to clean data. And these are the things that you have to be wary of to ensure that the data is consistent on each data source, and they can seamlessly talk to each other based off of the relationship that has been set. before you then start analyzing and exploring the data. Another issue or challenge is inconsistent entry methods. Different people may enter data differently, leading to spelling variations, formatting differences, and inconsistent terminology. This is very true and is one of the issues you will face in real world data cleaning, where people, for example, people might have to enter a course detail. Someone might decide to write the short form of that course. Someone might decide to write the full name of that course. For example, computer science. Someone might write CS, which also means computer science. Someone might write comp science. Someone might write computer science. So you see the way different people could write the same thing, but in different ways. These are issues that you can face when you're cleaning data. And these are things that you'll have to address to be able to be sure that CS means computer science and doesn't mean anything else. Comp science means computer science, and then you have to obviously transform those data to probably mean one thing. So if you want to stick to CS as the consistent format for that to mean computer science for your data, you can stick to that. If you want comp science, you can just pretty much format or transform all of that data to say comp science, wherever it detects CS or computer science. So these are things that you want to watch out for. And these, I won't lie, one of the issues, this is one of the challenges that I would say sometimes it can be frustrating, because you have to pay very close attention and you have to be able to understand how you can break the data down to ensure consistency based off of this difference in entry methods. But a good way you can actually save yourself and make it easier for yourself, if you're in control of where or how this data is being collected, is to add like rules into the entry. So for example, you can add like a line where people are actually entering the course to say, do not write CS or do not write in short form, write the full name of the course. So these are things that you can put in there. Obviously, not everyone follows rules, apparently, but that way you can still be able to reduce the amount of work you're going to do on your end if you're trying to clean the data. Or you can even add what's it called, options for them, so they can select the option. So whatever data that is, or whatever option is selected, you know, is consistent across all entries. So those are ways that you can kind of make it easy, make your data cleaning process easier if you're in control of how the data is collected. Another challenge is hidden issues. There are some problems that are obvious at a glance, while some are not obvious at a glance. And a good one was the data flow. It wasn't obvious at a glance. The funny thing was, my team member actually sent the value over, and that was incorrect, until the person that received that data said, a report said, oh, this seems kind of incorrect because of something that doesn't match what we had before. And when I had to then step in and check, that was when I realized, oh, there is an incomplete data, incomplete student record in the student details. So that was hidden, and I wouldn't blame my colleague, because it's something that you could overlook, right? People make mistakes, but this is where you also have to be careful, because you don't want to use a mistake that you could have avoided as your leeway, pretty much. And then common challenges is time investment. When you're cleaning data, time flies. I'm just being honest, time flies, because you're dealing with so many issues at the same time, and you're trying to spot so many things at the same time and trying to fix them, that you've just realized, yo, I've spent an hour, 2 hours just trying to clean this data and I'm still not done. So time investment for sure is one of the major challenges in data cleaning. So cleaning can take considerable time, especially for large or complex data sets with widespread quality issues. And then ambiguous values. Ambiguous values are basically values that are not always clear, whether a value is wrong, missing, or simply unusual, requiring careful judgment. So this is where you can't really tell if a value is actually wrong, or if it's right, or if it's missing. Like, what I mean by that is, if it's missing, is it very useful? If it's wrong, how do you tell that it is wrong? So this is where you have to obviously careful judgment is required, and this might require you to check in with the team or whoever is responsible for that data entry to confirm, okay, what exactly would be the correct data that should be in this record, things like that. So that way you can then exercise correct judgment on the data while you're cleaning. Let's go to the next slide. So what are the principles of good data cleaning? The first principle I would say is work systematically. Apply careful, methodical approach to identifying issues. If you have a workflow of how you approach data cleaning, like you fix the data format first, and then you look for data, remove, you remove. So what I would say is obviously fixing the data format, cleaning the data in terms of like standardizing the data. So you want to remove spaces, ensure that the spellings are correct, ensure that the data is consistent in terms of United States and United States, for example. And then after all of that is done, you can then move on to removing duplicates to be sure that there are no duplicates and things like that. Checking for blank spaces, checking for errors, looking for the null values and seeing if those values that are null are necessary for your data report or not. So as long as you have a specific process that you follow and you're carefully following that process to ensure that you can identify those issues, you will be able to get a very good result when cleaning data. Another one, and a keynote that I would say is also take notes. Take notes, because it's very easy to forget. Oh, what next you wanted to check, even if you notice something. So take notes. Oh, you noticed this, note it down if you're currently still doing a certain process of that data cleaning, and then you can go back to it. Oh yeah, I wanted to check this. So then you check it, and then you might find, oh, this is another issue that I need to face. Then the next step I'll say is preserving originals. Keep source data unchanged where possible. Do not make the beginner mistake of working directly on the source data. Always make copies when you're analyzing or cleaning data. Because the thing is, if you delete a row or delete a record that you think obviously is not needed, and for some reason that record is needed, and you've now made that change on the original data, is gone. It's gone. And you always want to avoid that issue, because that would then put you on this down spiral of panicking, anxiety, also depending on how important that data that you've just deleted is. And then it might cause extra work for the company as a whole. So you always want to work on backups. Keep your originals separate, and then create a copy of it and do your data analysis and data cleaning off of that. What you can also do, a good practice, is when you have that copy, when you clean the data, you can save a copy of that clean data as well, and then create a copy from that for whatever thing you want to do after, because that might require you to then go back and do some changes. So therefore, it's like you have stages of your process saved somewhere as copies that you can always go back to at any point. And then apply consistent rules. Use uniform standards across all records. So the example I gave was, if, for example, the student number starts with 00, and you, on one table, you format that as a number, and on another table, you format it as a text. Now, you're having to deal with inconsistencies in those two tables, because some of those records that is formatted as a number would probably be 4 digits instead of 5 digits, 3 digits instead of 5, and this would all have 5 digits. Therefore, if you were to relate the same student, but because they have inconsistent amount of digits, so 00457, and this one just has 457, that would not link. So that relationship is broken there. And another thing is document changes. You want to record what was corrected and why. That was the example I gave. You save the original, and then you create a record for your clean data. You create another record or copy of it for something else that you have to do, and obviously you just have those records down, so it's easy for you to pretty much pass that on to someone else that probably wants to take up that data cleaning process or data analysis process, so they know exactly how you approached it. Or even for yourself later on, it might be something that you've worked on 2 years ago, and now you have to kind of like refer back to those to what you've worked on, instead of pretty much just throwing yourself in the deep end and trying to figure everything out. You already have that process outlined for you, so it's easy for you to know, okay, this is what was changed, this is the result of what was changed, this is what we have now, this is where I can build up from. And then another process is to review results. You want to verify cleaned data meets quality standards. And then the last is to focus on quality, to balance detailed work with overall data integrity. So what are the key takeaways? The key takeaway is foundational step. Data cleaning is a critical first step in any data work. Quality matters. It improves accuracy, consistency, and trust in data. Dirty data risks. Unclean data weakens analysis and reporting, and it reduces trust in both the data that is not cleaned and both yourself. Because if you are providing reports or visualizations that on based off of unclean data, and that is leading to wrong decisions being made, and that is figured out later, your manager would not trust you. Your manager's manager will not trust you. Your teammates will not trust you because they can't trust you enough to provide them with accurate data. So it's very, very essential that you clean your data. So another key takeaway is to quality process. Cleaning is a systematic quality process, not just technical work. You have to pay attention to ensure that you're giving a quality result or quality data, and accurate, complete data. Then it helps with better decisions. Improved data quality leads to better decisions. If you have a correct data that says A is A and B is B, you are 100% sure that whatever decision you're making is based off of that and it is correct. So always remember, before data can inform decisions, it must first be made reliable. And that will be the end of this session on data cleaning. I hope you were able to gain enough knowledge on how to approach data, clean data, on the things that you could do to make sure that your data is complete, usable, and also mistakes that you can avoid when cleaning data. Thank you very much for attending this session. And if you have any questions, please let me know. But if we don't have any questions, then I guess that will be the end of the session today. Thank you very much.